My name is Steve Podrachik. I'm the CEO of Seattle Avionics, and today we're talking about ADSB. This should be a good presentation. We've got a whole lot of people signed up for it, and we're going to try very hard not to disappoint you. So, without further ado, let's begin. Why should you listen to me? Well, hopefully that'll give you a little bit of a clue. One of the things that you may want to look at is all the different companies that we've worked with, and I'll talk about that in a second. But possibly the biggest reason is, well, you're already here, so you might as well just stick around. If this is on the Pacific and you're eating this during lunch, sit back, relax, and just take a look. My company, Seattle Avionics, has been making aviation programs since before there was an iPad, since before there was ADSB. We've been doing it for over 10 years now. We began making a product called Voyager that's won all kinds of awards with consumer aviation and so on. You should also listen to me because, in my opinion, I think you should listen to me because we sell data to all the companies and a lot more that you see on the left-hand side of the screen. So we sell data, our brand of aviation data, which we call chart data. We sell to Aspen, to Dynon, to several different parts of Bendix King. We also sell data that's used in multiple iPad applications, including WingX, FlyQ EFB, Bendix King's My Wingman. We work with multiple companies who make ADSB and GPS receivers like SageTech, Dual, Vertical Power, Advanced Flight Systems, lots of other companies. As I say, we've been to this barbecue before. And as I said, we make FlyQ EFB and Bendix King. So not only have we been selling data and making Windows apps, we actually make our own iPad applications too. We designed and implemented AOPA FlyQ EFB, and we work with Bendix King to implement My Wingman. So we've done 2 different iPad applications as well. We've also done some work on Android applications with FlyQ Pocket. Also, we're the only company, other than Jeppesen, to ever get the FAA certification for our data. So data, we know it. In addition, we make data for both the United States and for Europe. It isn't just the United States. So anyway, that is, at least in my humble opinion, why you should listen to us. So at this point, we're going to watch a charming presentation by the FAA. They whipped up a little video telling you all about ADSB and Next Gen, and I think it would be great to watch this. No, I'm not going to do that. Although I'm sure the video is very interesting, I'm going to talk you through it instead. So what is ADSB? First of all, ADSB is designed by the FAA to help with the implementation of the next-gen airspace. It has nothing to do with general aviation. The point behind the next-gen airspace is to be able to sequence commercial airliners faster, more efficiently, using less fuel, being kinder to the environment, all of that, to basically stuff more airplanes into a smaller space and get them on the ground and through the airspace faster. Certainly a laudable goal, but it has nothing to do with general aviation. The primary point of ADSB, notice I haven't even told you what it means yet. The primary point of ADSB is to help them segue traffic. They need to be able to sequence traffic into the system, out of the system very quickly. To do that, they need to know with a high degree of precision where all the aircraft are. Not just the big planes, but they also need to know where the Cessnas and the Pipers are, because of course we use the rest of the airspace as well. So the point behind ADSB is to monitor us, to know where the GA pilots are so that the airspace can be run more efficiently. Consequently, ADSB transmitters are going to be required when flying in Class A, which is to say in the flight levels, in Class B, Class C, and even in some Class E airspace by 2020. Okay, this is a mandate. You'll be required to have a transmitter in your plane. So what does ADSB actually stand for? In case you're curious, it means Automatic Dependent Surveillance Broadcast. There's a lot of somewhat frightening words in that statement if you've been watching what's happening with the NSA. So this is surveillance, it's automatic, it's broadcast, all of this good stuff. I think right away you know that although the FAA does a terrific job and they have great technicians, when it comes to coming up with things that don't scare us, maybe not so well. So ADSB is designed to watch where the airplanes are so they can better sequence where they are in the airspace. This incidentally is a global standard, and they use multiple frequencies, and we'll talk about that in a minute. But as a bonus, in the United States, only in the United States, by the way, they also broadcast weather. So it's not, this is kind of the carrot and the stick thing. The stick, I suppose, is that they're watching you. The carrot is that you get weather out of it and traffic. Okay, so this is a freebie that you get only in the United States. So just to be clear, again, it's not like the FAA woke up one morning and decided, hey, let's spend a couple $2 billion and create weather for general aviation pilots so they can get free weather. No, They're very nice people. They do a great job, but that is not what their goal was. The goal behind ADSB was to be able to monitor all the aircraft flying in the United States airspace more efficiently so that they can sequence airplanes in the system better. Okay. Now, I like to think of this as kind of an alphabet soup. There's a lot of acronyms involved in ADSB, and I'm just going to use most of these once just to get them out of the way. One is TISB. TISB stands for Traffic Information Service Broadcast. The point behind that is this is the main idea behind what ADSB is for. The broadcast part means that they are going to be broadcasting traffic information up to you with some huge caveats, and we're going to talk about that later in the presentation. Another one is FISB. FISB is not anything to do with a cat or anything like that. It's not like Mrs. Frisbee. It's Flight Information Service Broadcast. The point here is that you get all kinds of information about flight. It's mostly weather, but not entirely. You also get information about NOTAMs. You get information about TFRs and so on. Anything that could be very relevant to you while you're flying is what they're going to broadcast. And there will probably be more of this over time. The system is designed to be extensible, so you will see additional products coming to you through FISB later. There are two different frequencies involved. One frequency is 978 and one is 1090 ES, the ES standing for Extended Squitter. Really, that's what it means. The point behind the reason why there are two different frequencies are that the 1090 frequency is the global standard. That's what's used by the commercial airliners primarily. It's used by the big guys all around the world. The point behind that is to transmit traffic between aircraft. If you think about all the aircraft flying in the entire world as something like a World Wide Web, when the aircraft talk to each other, you create a gigantic web, essentially, of the aircraft speaking to each other, transmitting information. That makes it a lot more efficient than trying to transmit from every place on the globe. So 1090 is a global frequency. It's used by the aircraft, by airliners primarily, and it is just traffic. On the other hand, for those of us flying GA, flying a little bit lower, the frequency that they use is a United States only frequency, or mostly United States, which is 978. That would be used by most of the GA craft flying below the flight levels, and it is actually transmitted from the ground. So it's ground up. The bonus here is that you, of course, get traffic like you do in the 1090 frequency, but you also get the weather and all the other FISB services available. So we get a little bonus in the United States over the rest of the world, that we get weather information. In and out. These are two phrases that you hear a lot to do with ADSB. And for those of you on the West Coast, I'm not talking about the hamburger place. In and out means it receives data. It's an ADSB receiver. That's ADSB in. Out means that it's an ADSB transmitter. It transmits information. So data is being sent out of the system. ADSB out is the thing that's required by 2020. The FAA doesn't particularly care if you monitor this at all. They don't really care about ADSB in. That's a bonus for us as pilots. The whole point, remember, is for them to be able to track where we are so they can better sequence commercial airliners. And that's fine, okay? So ADSB is the one that's required by 2020. So how does this all work? Well, I'm not going to go, this is a relatively complex diagram, although to be honest, it's a pretty simplified diagram of what really happens. If you take a look on the left side of the screen, there's a tower broadcasting within a bubble. That, let's say, is a reception range of the aircraft. You're flying along your little Cessna over there, and that Cessna can receive weather, assuming that there is an ADSB, probably both in and out system on that plane. He can receive weather and traffic that's being broadcast on 978 from the ground. So the Cessna inside the bubble can receive traffic information. Again, assuming that it has ADSB out, which is to say it transmits as well. On the other hand, the Cessna, which is outside of the bubble, it has a little no symbol next to it. That one is too far away to be able to receive the traffic or weather information that's being sent from the ground station. Okay. On the other hand, though, that particular aircraft has what's called a dual channel, and we'll talk about that in a second, has a dual channel ADSB receiver. So though it can't receive anything on 978, the other frequency that it listens to, the 1090 megahertz frequency, it can hear traffic information being broadcast from the jet airliner above. Okay, so that aircraft, although it's outside of the bubble, can receive some traffic information because it's getting it from the airliner. It can't receive any weather information though because it's not being broadcast on 1090. Confused? Okay, we're going to simplify this a little bit in the next few slides, but I want to give you kind of an overview. Two different frequencies, one from the ground, one from the air. So let's talk about the coverage. The blue dots represent areas of coverage. The red speck in the middle of the dot is where the tower actually is. The blue circle is where you can probably receive it. Now I'll get into probably in a second. Right now, the coverage area is pretty good. It's not perfect though. It is getting better all the time. The FAA is putting a lot of effort into making this reception area better. As you probably noticed though, in the Rockies and in the upper Midwest essentially, there's not quite so much coverage. That's being built out. They originally, meaning the FAA originally expected to have that all built out by 2013. Offhand, I'd say they're probably not going to make it, but they are making good progress on it. So you are going to see really good coverage in all 50 states. One thing to keep in mind about ADSB, it is designed for in-flight. So generally speaking, there's no ground reception. Sometimes you get a little bit, but you really don't get any on the ground. It's primarily designed for in-flight only. It can be a few hundred feet or maybe 1,000 feet off the ground, and then you can begin receiving it. You do also have to have it in line of sight. So if you're on the wrong side of a mountain from an ADSB transmitter, you're not going to receive this. These are radio waves, at least with the 978 frequency, that are being broadcast from the ground. So if you can't, basically if the radio has to go through a mountain, you're not going to see it. What ADSB does is it transmits, as we talked about, weather and traffic information. Turns out though that the traffic information is highly problematic, and we're going to talk about that in length in a few slides. Frankly, this is kind of ironic because the purpose behind this is actually traffic. The whole point behind ADSB was traffic. However, again, the point behind ADSB wasn't so much to give us traffic, but to provide the FAA with the traffic patterns of all the aircraft in the system, big planes, small planes, everything in the middle, so that they could better sequence planes into the national airspace. That is the primary purpose. It isn't so much for us to see the traffic. Now, we'll talk about weather in a little bit more detail in a second. Weather right now is limited. It's not great. It has a lot of weather products. It doesn't have everything, but it is good. It's good enough. And it's free, or rather it's tax dollar supported. So the weather products that you get aren't as good as commercial products, but they're pretty good. So let's talk about the weather. What do you get? Well, right now, let's talk about the different weather products cover different areas of coverage, and they are broadcast at different frequencies. So let's talk first about the regional and next-rad radar. The regional and next-rad radar is kind of the medium resolution radar. There is no really high-res radar. There's nothing like the kind of quality that you can get, for example, with an XM receiver on the highest quality setting. What you get are regional settings. You don't get super high resolution stuff. So the regional radar has an area coverage, a radius of about 250 nautical miles, and at best, and I'll talk about that in a second, at best it's broadcast about every 2.5 minutes. Now, the reason why I said best case is because these receivers aren't perfect, the transmissions aren't perfect. It's a broadcast system. This isn't like the internet where you request some data and then the server sends it back to you. Rather, if you're listening for it and there's no problem with the transmission, nothing in the way, and so on, then you get the information. So you're going to miss some stuff. There's going to be a problem with the transmission once in a while. So this is a best case scenario. Best case, there'll be a radar refresh of the medium resolution regional next-rad radar every 2.5 minutes. They also do an entire composite of the United States, which is pretty low resolution. The US next-rad radar is the entire United States, and it's broadcast at best every 15 minutes. Now I say at best because it turns out that there are multiple types of ADSB towers. There are high-power towers, low-power towers, towers that only work on the ground. There's only a few of those. Only the high-power towers, and there are relatively few of those, transmit the US next-rad. So don't really expect to see that most of the time. You'll see that occasionally, and depending on the receiver that you use, you may be more likely to see it. But most of the time, you aren't going to see the national composite. But frankly, unless you're flying the SR-71, it really doesn't matter. METARs and TAFs are transmitted at different frequencies. They both cover 100 nautical miles, but the METARs are transmitted more often because, frankly, they change more often. So the METARs are rebroadcast every 5 minutes, the TAFs every 10 minutes. Now, a good point here to mention, although the METARs and the TAFs are broadcast fairly frequently, every 5 or 10 minutes, that doesn't mean that the data is any fresher. METARs are generally speaking only updated once an hour, and they're still only updated once an hour. They simply rebroadcast the same thing 12 times, okay, in an hour. The TAFs, they rebroadcast 6 times. So again, or actually more than that, the TAFs are only updated 4 times a day. So although they're rebroadcast, so that if you happen to be listening, you get it, that doesn't mean that the data is any fresher. Same thing with airmets and sigmets, which are broadcast every 5 minutes, and the winds aloft, of course, too. It's something to keep in mind. Although you get wind data, the wind data is only updated 3 times a day. So although it's rebroadcast fairly frequently, it's not like you're going to get up to the millisecond winds, not even close. So the winds that you get through the system, as you would get through XM, are the predicted winds aloft. They are not actual winds aloft. Okay. TFRs and NOTAMs are also broadcast. They cover a radius of about 100 nautical miles and are broadcast every 10 minutes. PIREPs cover a wider area, 500 miles, but also 10 minutes, and the same thing with special use airspace. Every 10 minutes, you get a 500 nautical mile swath. So again, just to be clear on this, the graphics that you get with this, which is to say the radar, are medium resolution. They are not as good as what you get with XM. There are also some weather products that you may have been missing. You don't have satellite, is the most obvious. There's no clouds, there's no satellite things here. You don't get a whole lot of things that you get with commercial products. And again, want to be really clear on this. Don't confuse the broadcast frequency, the 2 minutes, 5 minutes, 10 minutes thing, with how often the data itself is actually updated. The updates happen far less frequently. And again, the best case frequency for the update, it really is a best case. Most of the time that you fly, you're not going to see updates happen quite this often, at least if you're flying anywhere that has any kind of mountains or anything like that. Now, let's talk about traffic. This is a diagram or a similar diagram to one that a lot of people use. The general concept is that if you do have an ADSB out system, meaning an ADSB transmitter, okay, and I want to be really clear, I'll talk about this in a little more detail when we talk about the portable equipment that you use with an iPad, but there is no portable receiver that you can buy, none, which has ADSB out. They are all ADSB in. All of the portable devices that we're going to talk about are ADSB receivers only. Now, that's not a matter of no one being able to figure out how to make a transmitter or not want to spend the money on it. It's that the FAA will not certify something broadcasting its highly precise location to the FAA unless it is a certified unit. So to have an ADSB out system, you cannot use a portable device. You can have a portable device as well, which is pretty handy. But to really have a good sense of the traffic, you need to have an ADSB out. So anyway, the point is, if you have an ADSB out equipped plane, the ground station, which is the little logo down there, the ground station is going to broadcast up to you all the targets within what's often called a hockey puck. That is, it doesn't tell you all the aircraft in the entire country, or even in your whole region. What it does is it figures kind of a three-dimensional slice that it gives you. It looks out 15 nautical miles in all directions from your current position, so a 30 nautical mile diameter, 15 nautical mile radius, and it looks plus or minus 3,500 feet from where you are, and so 7,000 miles swath. So you kind of get a slice which is 7,000 feet tall by 30 miles wide. Okay, if you're within that, if there's another aircraft in that slice, you're going to be broadcast that information. Okay, so again, if you have an ADSB out system, you'll be told about all the aircraft that are relatively close to you. On the other hand, if you don't have an ADSB equipped system, and most people don't, if you don't have an ADSB out system, but you do have ADSB in, like any of these portable receivers, you can essentially eavesdrop on the transmission meant for someone else. Again, the tower is not broadcasting point to point to the other aircraft. Rather, it's broadcasting to anything that's listening in the area. Okay, and that's pretty handy. So, consequently, if you're the little aircraft down the bottom, the little red Cessna with a green circle around it, that aircraft can see all the traffic that the Cessna Citation jet above it can see. Okay, so there, in this particular example, your aircraft is down below the Citation jet, and you see two little red aircraft in its hockey puck. Consequently, your Cessna is going to know about the two aircraft which are nearby the Citation jet. But it's not going to know about the three other Cessnas, which are much lower than that, which are outside of the hockey puck from the Citation jet. And this is a really key point, that although there's an aircraft in the area that has an ADSB out, which is forcing the tower to transmit traffic, the tower doesn't transmit all the traffic in the area. It only transmits the traffic that is relevant to the aircraft, or multiple aircraft, which are broadcasting locations to the tower. Okay, so you could easily have 2 or 3 planes with ADSB out in the system, and there'd be essentially 2 or 3 hockey pucks of information that are being broadcast to everyone. But if an aircraft is in the area, but doesn't happen to be within one of these hockey pucks, you're not going to know about it. Okay, this is a really, really key point. So, pop quiz time. Right now, this is a Bendix King My Wingman product. It has ADSB built in. It has ADSB traffic built in, and we're using an ADSB receiver that has all the information it needs for traffic. So, I don't see any traffic on the screen. That means that there are no planes in the area, right? No, it doesn't. What it could mean, or rather it could mean that, but it also could mean that there are lots and lots of planes, but simply none of them have ADSB out. And this is really crucial, that you can be flying in a place that has tons of aircraft traffic and even tons of people flying with iPads and with ADSB receivers. But if nobody in the vicinity has ADSB out, you're not going to see any of them, and they're not going to see you. Okay, key point to understand about ADSB. So the bottom line, if your plane doesn't have an ADSB out system, you really have no idea what the traffic is. Any plane that you see on your system is a plane that really exists and you should avoid. But there could be one, more, or 100 of them, other planes that you simply don't see because you don't have ADSB out. So the bottom line is, if you really want to use an ADSB traffic system, it's extraordinarily good to have the certified ADSB out system installed in your plane. And you're going to have to do that, by the way, by 2020. So again, if you have an ADSB receiver only, you are going to miss traffic. Sometimes you're going to see nothing on your screen when there's lots of traffic. Other times you'll see some planes, but not all planes. So the bottom line is, if you have an ADSB traffic display, it's useful to know what planes are definitely there, but it absolutely, positively, unequivocally does not mean that you shouldn't be looking at the aircraft, constantly scanning for aircraft, because there very, very well may be other planes out there. All right, so let's talk a little bit about the hardware. There are lots of different vendors who sell ADSB receivers. Just going from the upper left over. The one in the upper left is a Stratus ADSB, the Stratus 2 receiver. The one in the middle is a Clarity SV receiver. The one on the upper right is a Dual X GPS 170. Below the Stratus, in what I kind of think looks like, frankly, like a submarine, is the GDL39 from Garmin. The one with a solar panel below the Clarity unit is the iLevel ADSB receiver. And the one with the two antennas sticking out of it is the SkyRadar L model unit. Okay, there are more of these. Many of these vendors make more than one ADSB receiver, and there are still more ADSB receivers. These are just some of the more common ones. So this is, I hate to do a grid, but I'm going to try talking you through this because it does make a lot of difference. When you take a look at all the ADSB receivers, basically none of them work with all the ADSB. No ADSB receiver works with every app. And there is no app that works with every ADSB receiver. So you kind of have to pick and choose. So I'm going to go over this kind of column by column. The columns will be which apps does it work with? Is this a single channel, which is to say 978 ground-based transmission only? Or is it a dual channel receiver that can also receive traffic, but not weather, traffic information from commercial airliners? Does it include an AHRS? That is, does it have a synthetic gyros in it? Yaw, pitch, and roll. Is that built into the system as well? By the way, all of these have a built-in, I think all of them do anyway, have a built-in WAS-enabled GPS. So you always get an external GPS, which is great for all the iPad apps. So you don't have to rely upon the one that's built into your iPad. They all have a built-in GPS, so I didn't even put that on the grid. Most of them run on batteries. Most of them have a lithium-ion battery that's rechargeable. A couple of them don't, and we'll talk about that. There's two different ways that the ADSB receiver can talk to the iPad. The iPad doesn't have a standard USB connection. So the only way that you can talk to it is through some kind of a wireless connection. You can talk to it either through Wi-Fi or through Bluetooth. Sorry, an H got cut off the end there. Either through Wi-Fi or Bluetooth. And then the different prices. The prices go anywhere from about $600 all the way up to $1,400. Okay, so let's talk about these in a little bit of detail. In terms of applications go, the Clarity receiver and the Clarity SV are very similar receivers. They work with FlyQ EFB, works with WingX, works with the Bendix King My Wingman, and I believe some other applications as well. The difference between the Clarity and the Clarity SV is simply the SV stands for synthetic vision, and it includes an AHRS. Okay, so it'll give you three-dimensional yaw, pitch, and roll. So if the applications you're using supports three-dimensional display, 3D synthetic vision, the Clarity SV model is a great choice. Both of the Clarity units are dual channel. Again, that means that they receive weather and traffic information from the ground on 978, and they also receive traffic information, but again, not weather, from 1090 from aircraft flying overhead. They both have a battery life. I don't remember the number, but it's like 6 or 8 hours of battery. And they use the Wi-Fi technology to transmit. So let's talk about Wi-Fi versus Bluetooth since we're here. Since an iPad can only talk to a device through some kind of a wireless connection, the vendors had to pick either to use Bluetooth or Wi-Fi. What's the difference? Wi-Fi is something that your iPad can only hook up to one Wi-Fi device at a time. If you think about being at home or in a Starbucks or a hotel or something, you connect to a Wi-Fi system and then you're good to go. You never connect to multiple Wi-Fi systems. What that means is that any device which is dependent upon Wi-Fi, like the Clarity receiver or like most of the receivers here, it means that your iPad cannot connect to Wi-Fi on any other system. Meaning, if you're connected to this and you're sitting at the ground, or you have Wi-Fi, or you have another device that wants to use Wi-Fi, you can't talk to any of those. So if you were on the ground and you want to use the FBO's Wi-Fi to talk to the internet, to check your mail, to get weather, whatever it was, you couldn't do that because your ADSB receiver is using the only available Wi-Fi slot. Okay. On the other hand, if you have a Bluetooth-based system, then you have a little bit more flexibility. With Bluetooth, you can connect any number of Bluetooth devices to an iPad, a keyboard, a mouse, whatever it may be. Multiple devices can connect to an iPad at the time with Bluetooth. It's also just plain easier to connect to. They automatically connect. And with the Wi-Fi based system, you have to go into the settings on your iPad and specifically tell it the name of the Wi-Fi network which is being broadcast by the ADSB receiver. So it's not really that hard to do, but it's one more thing to do in the cockpit if you have a Wi-Fi based system. On the other hand, and there are a lot of hands in this, the Wi-Fi based system allows more than one iPad to talk to it at the same time. So if you're flying and you have 2 or 3 different ADSB, you have a couple of different iPads hooked up to multiple EFB systems, and you want to be able to have every iPad talk to the same ADSB receiver, Wi-Fi is your best choice. Now, some of the Bluetooth systems support more than one device, typically 2, but in terms of reliability, you still get better reliability if you want to hook up multiple devices with a Wi-Fi based system. Anyway, so the Clarity systems are about $1,100 for the one without the AHRS, and it's about $1,400 for the one that includes the AHRS. And again, that's supported by a lot of applications, FlyQ, WingX, and by Bendix King's MyWingman. Stratus is probably one that you know of. There are actually, again, 2 different Stratus receivers. There's the original Stratus, and then there's one that was in the screenshot before, which is of the new Stratus 2. The Stratus receiver only works with ForeFlight. ForeFlight only works with Stratus. Okay, they are joined to the hip, as it were. The original Stratus receiver is a single channel receiver. It receives from the ground, the 978, weather and traffic, although as I recall, it doesn't display traffic anyway. It does not include an AHRS, it is battery powered, and it uses Wi-Fi. It's also a good price, it's $599. You get that through Sporties. The Stratus 2 is their newer model. It's smaller, sleeker, has a built-in fan to try to keep the unit cooler. It uses a dual channel system, so it, like the Clarity's, talks to 2 different talks to 978 on the ground and 1090 in the air. It does include an AHRS, but curiously, the AHRS is not used in ForeFlight. Now, presumably, or one may conjecture, that that'll be something that they add soon. But at the moment, the AHRS that's built into Stratus 2 is not used in the only software that can use it, which is kind of strange. It has a built-in battery. It uses Wi-Fi, and that one's a bit more. That's $899. The DualX GPS 170 is supported by, I have 3 icons here, FlyQ, WingX, and Bendix King, my wingman, but I'm told they actually support a number of other iPad apps that are a little less popular. So in terms of breadth of coverage, I think that the DualX GPS 170 probably wins. This is a single channel receiver, 978 only. It does not include an AHRS. It does run on batteries, and this is one of the few in the group that uses Bluetooth. Bluetooth, again, means it's a little easier to connect to. And it's also a great price, it's $599. The Garmin GDL39 is a terrific ADSB receiver. Unfortunately, it only works with one application. It works with the Garmin Pilot app, and the Garmin Pilot app only works with the Garmin receiver. This is a nice receiver, though. It's a dual channel receiver. It does not include an AHRS. It is battery powered, and like the Dual, it uses Bluetooth, and it's a pretty good price. It's $699. So as far as dual channel receivers go, it's a pretty good buy. But again, it limits you to working with one application, Garmin Pilot. The eye-level receiver. Eye-level has been making AHRS systems for a number of years. You may remember they have a product called the Mini G, which is a Wi-Fi based AHRS and GPS system only. The eye-level builds on that by completely redesigning the package. It's a lot slicker package. But they also added in ADSB. They actually make two different models. I only listed one for space. The SW is a model that they make. It is a single channel receiver. It does include an AHRS because it's eye level, it's level, and that's what they do. It also, which is kind of clever, not only includes a battery, but it includes a solar power battery thing on it. The solar system on it doesn't have enough power to fully charge the unit, but it does mean that discharge is slower. So you get a better battery life out of it because of the solar panel built into it. It is Wi-Fi based, and its price right now looks like it's $10.95. By the way, about 2 hours before the presentation, I tried to find the lowest prices for all these receivers on the internet. So that's what we have. Sky Radar is a system that's been in the market probably the longest. They make two different models, the Sky Radar L and the Sky Radar D. At the moment, by the way, the eye level currently only works with WingX. That will be added to FlyQ in the near future. The Sky Level receiver is currently supported by WingX, and I think just WingX and the Sky Radar's own application. The Sky Radar L is our original unit. It is a single channel receiver. It does not include an AHRS. Doesn't include a battery either. You have to plug it in, which is pretty unusual. And it is Wi-Fi based. It's also a good price. It's $5.99. I put an asterisk next to it though, because according to their website, they're out of stock on it. So you can't buy it right now anyway. I don't know if it's going to be back in stock later, but at the moment it's not available. A newer unit, the Sky Radar D, is a little smaller, a little slicker. And this is a dual channel system. It does use an AHRS, also doesn't use a battery, and is Wi-Fi based and only costs $6.99. Okay, I want to be really clear about one thing. And again, for those of you just logging into this, the presentation that you're doing, in case you're taking copious notes on this or doing screenshots or something, the presentation is being recorded. You will be able to watch it later. In addition, the actual PowerPoint presentation, although I didn't really use PowerPoint, but the PowerPoint presentation will be available after the presentation for download, so you can take a look at that. Now, key point here again, I got to be really clear on this. No device on this list, no portable ADSB device at all, will satisfy the mandate, the law, that in 2020 the FAA mandates that you must have an ADSB transmitter in your plane. Once again, all of these units and all portable units are receive only. They are not allowed to transmit because the FAA and possibly the FCC doesn't want something in the aircraft transmitting its position from an uncertified GPS. Okay, so again, although all of these systems are great for downloading weather and looking at traffic, none of them relieve you of the responsibility of getting a certified ADSB out system put into your plane by 2020. Now, this next slide, I have to be really clear. There's a big SageTech logo on it because I want everyone to really understand this is where it comes from. The point is that when you get a GPS, by this point, GPSs have been around for a long time. They all, to a large extent, work about as well as some other ones. There's a little bit of variation in them, but a GPS, to a large extent, is a GPS. You cannot say that for an ADSB receiver. There is, in fact, a huge difference in these receivers across a lot of dimensions. How well they deal with heat, how big they are, did they use, things like that. And one of the big things is the reception. Now, I'm not showing this to push any one receiver necessarily. I'm showing you this so you understand that you need to look at any ADSB receiver that you're thinking about, really kick the tires, read the reviews, understand how good is the ADSB receiver for what you need. In particular, if you take a look at this graph here from SageTech, this is a flight taken from Hood River, Oregon, which is not too far away from us here in Seattle. It looks like it's about 110 nautical miles away. Basically, the flight went over the mountains and flew from Hood River, Oregon into the Seattle airspace. There are two lines on the chart. In this particular flight, if you take a look down the bottom at the photograph, this flight was taken by someone at SageTech with a Cessna 182. He was flying at 8,500 feet. It was his cruising altitude. And he had the SageTech receiver with a solar shade on it, which is on the left. And he had the Stratus 2 on the right. Both were essentially sitting in the same spot on the dash. What he wanted to do was to see how the performance of the two different systems were. When you take a look at the graph, the blue bar is Clarity SV in terms of number of towers it can receive. Technically, you only need one tower of reception to be able to get weather and traffic, But as with all things, if you get 2 or 3, it's a more reliable signal. So in this particular flight, shortly after takeoff, the Clarity SV picked up its first tower, and that was after, looks like about 3 miles away from takeoff. And then by the time you got to about 12 miles, it had picked up 3 towers and so on. It kept building and building. So it had a continuous lock on at least 1 tower, more or less the entire flight. The Stratus, on the other hand, didn't pick up its first tower until over 50 miles into the flight. That is, in this particular example anyway, the Stratus 2 receiver didn't pick up any weather or traffic information until you're halfway done with your flight. And even then, it looked like it was kind of marginal for about 10 miles. By the time it got into the Seattle area, it did manage to pick up, looks like a consistent number of towers, but it took a while for that to happen. So the point here, again, isn't that any one receiver is necessarily better than the other. It's do not assume that because a system has ADSB, or because it's single channel versus dual channel, or whatever it may be, that has a lot to do with how good of a receiver it is. That has a lot more to do with the internals of the device itself, how it's designed, how it's manufactured, and so on. So kick the tires a lot. All ADSB receivers are not created equal. So let's talk about apps a little bit. These are the, if you saw the iPads in the cockpit presentation I gave last week, and we'll give again tomorrow, these are the same 5 applications I talked about there. Not because these are not necessarily the best in the market, but because these are probably the most popular in the market. Certainly the most popular is FlyQ. It has, in terms of ADSB, it has excellent presentation. They have a good representation of all the weather products. They have a good representation for how good the quality, like signal strength and where the satellites are, where the ground stations are. It's a good system. However, it only works with Stratus, and I want to be really clear on that. That if you have FlyQ, the only choice that you have in ADSB receivers is the Stratus 1 or the Stratus 2. Similarly, if you have a Stratus 1 or a Stratus 2, the only application you can use is FlyQ. Now, hopefully you got the impression that there's a lot of good receivers out there, and presumably there'll be a lot more receivers out in the future. So that is something to keep in mind, that if you go with Stratus or you go with FlyQ, you're locking yourself into one solution. Also, FlyQ, although the Stratus 2 receiver, again, I mentioned this before, the Stratus 2 receiver has an AHRS, has a 3-dimensional yaw, pitch, and roll system in it that is not currently built into FlyQ. There's a separate application, which if you look at the cover of Sporties, for example, you're actually looking to screenshot from FlyQ and then from another application that comes from Stratus. So you can't get the yaw, pitch, and roll and the 3-dimensional benefits of having an AHRS directly from FlyQ, at least not yet. Another good thing though, is that they are one of the only 2 different EFB products that also supports XM weather. So if you want to get better weather than what you can get from, with an ADSB system, like satellite, cloud tops, precipitation, lots and lots of weather products, FlyQ also does work with an XM receiver. WingX. WingX is also, of course, a very popular product. It has, if you're familiar with WingX, WingX is very heavy on giving you lots and lots and lots of information. And ADSB is like that as well. So with WingX, you get a lot of data that's put onto the map. You have a lot of data in various status windows that can tell you all what's going on with the ADSB system and so on. A lot of information that you can get from ADSB with WingX. WingX also has more receivers than anyone else. In fact, for the number of receivers I listed previously, I listed 6 or 7 receivers. All but 2 of them work with WingX. So they definitely have the best coverage. In terms of the ability to talk to different systems, WingX wins that one hands down. FlyQ EFB from AOPA, and again, worked from our sponsor, just designed by Seattle Avionics, so I'm most familiar with this product. This one currently supports 3 different boxes, includes the Clarity SV, and the DualX GPS 170. The eye level is coming soon, and we're looking at more of them as well. One of the things that's unique, so this displays the usual radar, radar, METARs, TAFs, winds aloft. It is actually the only one on here that doesn't display traffic. And the reason why it doesn't display traffic is because, frankly, this was my choice. It doesn't display traffic because we are very concerned, given the caveats that you saw in the presentation earlier, that a lot of people would be using it and relying incorrectly on the traffic information that's displayed. That doesn't mean we won't add it. In fact, we are going to add it with a big warning the first time you turn on. But at the moment, FlyQ EFB, although the ADSB receiver is supported, it doesn't currently, and again, currently is a key point here, display traffic. Garmin Pilot is a great application. They have a lot of great features in the app if you saw the other presentation. But they, like FlyQ, they only support one ADSB receiver. It's a pretty good one. The Garmin GDL39 is a good receiver. It doesn't include an AHRS though. But of course, Garmin Pilot also doesn't have any three-dimensional display like FlyQ doesn't. So I guess there's no point to it. The Garmin Pilot is the other system that also supports an XM receiver. So again, if you already have XM, or if you fly in a soup a lot and you want to get even better weather than what you can get with an ADSB system, then that is a good choice. The Garmin Pilot is a good choice there. Another application is Bendix King My Wingman product. It supports the Clarity and the Clarity SV and the dual receiver. Unlike FlyQ, although we created both products, unlike FlyQ, it does include a traffic display. In fact, in the presentation earlier, I used screenshots from Bendix King's My Wingman to display traffic. Okay, so all of these applications support some, at least one ADSB receiver. Some of them support lots of ADSB receivers, and some of them support a few of them. And all but one of them support traffic. Okay, so that's a little quick tip about the apps. So, bottom line, you got to be really careful. This is not like the GPS. Not all receivers are the same. They are, in fact, quite a bit different, or can be, in terms of the way they handle heat, the way they handle receptivity, possibly the way that their GPS is, the way that they communicate with the iPad. There's a lot of, the price tag. There's a lot of differences between the ADSB receivers. Do not assume that just because it has a particular feature that it's the same as all the other models. There's a lot of variation. ADSB is very, very young. Keep that in mind. That for all of you expecting Santa Claus or Hanukkah Harry to give you an ADSB receiver this year, you'll find that this is a very immature market still on ADSB receivers. There's a lot happening in it. There'll be a lot of new models coming out, which, to be honest with you, is the point, which is why I recommend the second one. The second point here is we really strongly suggest that you avoid any application that works only with one device. Similarly, avoid any device that works only with one app. And the reason for that is crystal clear. There's a huge amount of activity right now with iPads and with ADSB system. There's a lot of new applications coming online. There's a lot of new ADSB receivers coming online. If you want to make sure that the expensive investment you make in an ADSB receiver works with your iPad application, then you have to buy one. You have to buy an ADSB receiver that works with more than one app. Okay? We really recommend, again, given the amount of activity happening with iPad EFBs and the amount of activity happening with ADSB receivers, that you do not lock yourself into one device or one application. There's simply no reason to right now. There's too many applications to work with more than one receiver. Right now, the coverage area isn't quite what the FAA would like it to be. It is good right now. It is definitely getting better. It does include all 50 states, but it is not perfect. In particular, if you fly in Montana or North Dakota or a few places like that, or maybe even in Colorado, some of the coverage isn't as good as you may like it to be. So if you need absolutely great coverage, an XM receiver is definitely going to work better than ADSB, which is the next point too. The weather products that you only get, 5, 6 different weather products. You get the METARs, TAFs, radar, winds aloft. You get all the basics, but there's a lot more detailed or maybe even esoteric products that you can get from, say, an XM system that you don't get from an ADSB receiver. So keep that in mind. Also, the receptivity, since it's being sent from the ground. Remember, if you have a dual channel receiver, that dual channel is not going to broadcast to you weather information from the airliners. The 1090 frequency, 1090 ES, the one being broadcast from the airliners, is traffic only. There is no weather being broadcast from that. So to get weather, you have to be relatively near a ground-based receiver, and you have to be more or less line of sight. So if there's a mountain or really bad weather or something like that, you may not get weather. So weather is a little bit more problematic from a satellite-based system, and you need to understand that. Also, although getting one of these devices is tremendously useful in the cockpit to get weather and or to get traffic, none of them, remember, satisfy the mandate that by 2020, if you fly more or less any place in the national airspace, that you need to have a transmitter in the plane. You need to have ADSB out. And there's probably very, very little chance that the portable ADSB system is ever going to be certified for that. The FAA, keep in mind again that the point behind ADSB is not to give you weather, it's not to give you traffic. It's so that ATC knows with a high degree of precision exactly where every aircraft is. They do that so that they can sequence the commercial airliners better and more efficiently. To be able to do that, they really do need to have an accurate GPS. They need to know precisely where you are. Consequently, they will not allow any portable system with an uncertified GPS to broadcast its location to ATC. They just don't trust it, and that's understandable. So if you want to meet the mandate, and you're going to have to by 2020, then you have to get an ADSB out system. Now that said, you actually can get a relatively inexpensive ADSB out only system. That's really all the mandate is. And then you can use an iPad application and a second ADSB, an inexpensive portable receiver, to get your weather and traffic from it. The mandate, again, is not that you actually have to have ADSB in and out, that strictly that you have to have ADSB out so that the FAA knows where you are. They really don't care if you know where the other planes are. This is a really, really key point. I hope if nothing else, that you got this from the presentation, that the traffic that you see through an ADSB-based system, unless you have ADSB out, and a big caveat there, unless you have ADSB out, the traffic that you're looking at on any iPad application, on any system, whether it's single channel or dual channel, absolutely positively should not be relied upon. If you see a plane on your scope, there's probably a plane there. The problem is, if you don't see a plane, or if you don't see any planes, you have absolutely no way of knowing whether that's because there really is no plane there, or simply that there's no ADSB out equipped aircraft in the area. Or there even could be ADSB out aircraft in the area, but there are planes that are outside of its little hockey puck that you don't see, that are possibly a threat to you, but not a threat to the system which is doing the ADSB broadcasting. Okay, so really important. The traffic that you see on these systems, it's nice to have, but absolutely, positively, please don't do this. Please do not stop looking out the cockpit. Okay, the only way that you can be sure about traffic is to listen to ATC, if you're doing that, and to look outside the cockpit. Having an iPad with an ADSB receiver absolutely does not relieve the pilot's responsibility for taking your eyes and looking outside the airplane. Okay, be really careful about that. That said, if you have a dual channel ADSB receiver, it definitely does help. You're much more likely to get traffic. But again, you can't absolutely rely upon it. And I hope nobody does. So anyway, that's pretty much our presentation. I do want to do a little bit of what I like to call the word from our sponsor today. As we said at the beginning of the presentation, Seattle Avionics supplies the data for many different iPad applications, including FlyQ, WingX, My Wingman, lots of different folks. We make our own applications, AOPA FlyQ, and so on, and we sell a number of different ADSB receivers and GPS receivers. We sell a lot of stuff. In particular, we sell a lot of stuff on Black Friday. So in less than a week, in about a week or so, Black Friday is happening. On Black Friday, we're going to be having, and we've done this in multiple years in the past, so I know what's going to happen here. We do a one-day special on just about everything we sell. These are tremendous specials. If you're in the market for getting an ADSB receiver or data for your Dynon, or if you're Aspen, or if your iPad application, whatever it is, you will get a tremendously good deal by checking back with us on Black Friday, on this Friday. I do have to point out that in most cases, the quantity that we sell is limited. We are selling for very, very low margins on that day, and there's a limit to it. So what we suggest people do, if you're interested in the discounts, is to sign up and follow Seattle Avionics on Twitter. You do that, it's not very hard to do. You just go to twitter.com/Seattle Avionics, and you click a button that says follow. If you don't do that, that's fine. We know a lot of people don't use Twitter. If you don't use Twitter, you'll get an email from us on Friday morning. The only point here is that because of the quantity limited, you're much more likely to get the offer that you want if you do follow us on Twitter. So at this point, I'm going to stop talking. A few more things to follow up. Number one, there are more webinars, at least one left. Tomorrow, we're doing a repeat of our extremely popular webinar, which was called iPads in the Cockpit. iPads in the Cockpit talks about selecting different iPad models, selecting ADSB receivers, does a survey of 5 or 6 different iPad applications, and so on. Kind of the tips and tricks to using an iPad. It doesn't have anything to do with a particular device or a particular application. It's a general overview of using iPads in the cockpit. And it was the most popular presentation we've given so far. It was extremely popular. Also, when you go to seattleavionics.com/webinars to sign up, for example, for iPads in the cockpit tomorrow, you can also review all of the pre-recorded webinars we did in this past week. That includes, again, iPads in the cockpit. It will include this presentation as of tomorrow, or probably in a few hours from now. Includes multiple presentations we did for a Voyager for Windows product, and so on. So if you're interested in learning more about anything to do with Windows or to do with iPads or ADSB, go to seattleavionics.com/webinars. In addition, a few more things that may be helpful to you. In addition to this particular presentation, which you can download right now from our website, there's also an ADSB primer in PDF form that you can take a look at. If you go to seattleavionics.com/documents/ADSB _ there's an underscore there, _primer.pdf, there's about a 3 or 4 page document that talks about a lot of the same things I spoke about here, but in printed format that you can read. So again, that's the ADSB primer. You can get that from seattleavionics.com/documents/ADS-B _ primer.pdf. And again, this presentation, or one very, very similar to, it actually was modified a little bit after this PowerPoint was made. But this presentation is available as a zip file that unzips into a standard PowerPoint that you should be able to look at on a PC or on a Mac. You can download that from seattleavionics.com/documents/allthingsadsb.zip. Okay? So what I'm going to do now is I'm going to stop talking. We still have a whole lot of people online right now, and we have a whole lot of people in another room answering questions. So I'm not going to terminate the presentation. I'm simply going to walk away and help all these questions being answered. You've been very kind. I appreciate you spending the afternoon with me. The weather is terrific here in Seattle, and I hope the weather where you are is just as well. So have a great day, and remember to follow us on twitter.com/seattleavionics to get those specials on Friday, and to review any other webinar that we've done by going to seattleavionics.com/webinars. My name is Steve Petracek for Seattle Avionics. Thank you very much.